So for our next session, I have the honor of moderating it with Ghassan Abou Alfa, who I believe is joining us remotely. Hello, Ghassan.
Hi, good afternoon, Lipika, and good afternoon, everybody. And I have to second what you just mentioned. Mr. Sverstava, I have to say, beyond touching, great works, great learning lessons for all of us. And of course, this is really what drives us to continue to do the work that we do. Thank you very much. And with this said, I'm going to carry on. It's my great honor and pleasure to co-chair with Dr. Goyal. And I think we'll carry on right away. And we'll kind of, keep exchanging microphones, virtual and in person. But I really could not but, we thought over is going to present Dr. Shroff because she's a great for both of us. And I really kind of squeezed arms, but because, as you all know, Dr. Shroff is one of my great colleagues whom really I greatly honored to present this afternoon. As you know, Dr. Shroff is the Associate Dean for Clinical and Interstitial Research and Associate Professor at the GI Medical Oncology at University of Arizona Cancer Center, where she served as the chief for the section of GI Oncology. And Dr. Shroff has been really a key player in regard to the field in cholangiocarcinoma. And of course, what else but she's going to tell us about the hottest target therapy on the horizon for cholangiocarcinoma. Rachna, the floor is yours.
Thank you very much. And Francesco, I just wanted to invite you on. Thank you.
Thank you so much for that kind introduction, and what a fantastic way to kick off the afternoon. Thank you, Mr. Srivastava, for sharing your story. It is my privilege and honor to be here speaking to you today about some of the hottest targeted therapies on the horizon. For those of you who know me, my favorite thing to do is to infuse pop culture into my talks. I take it as a challenge. So today's theme is R&B hip hop. So the question is, who's going to run this town when it comes to targeted therapies? These are my disclosures. So, there's a lot of talk that's been going on about FGFR2 fusions. We're actually going to hear about the next generation very shortly, and I'm very excited for that conversation. But I think my job was to talk about some of the other areas that are really exciting and are potentially targetable, actionable, and are in the works in terms of becoming available to our patients. And that includes those little circles that are listed up there, including things that we have already talked about, like IDH, but kind of the next generation of IDH, as well as some newer, but albeit rarer targets. So obviously, we know that the IDH story really started with this study. This is the Clarity trial. I'm obviously not going to go into this or belabor it, but this was the pivotal phase 3 that led to the FDA approval for ivosidenib, our first IDH1 inhibitor available to us. This was based on the study meeting its primary endpoint of markedly, significantly, statistically improving progression-free survival compared to placebo. But now we're starting to think through what else can we do in the IDH space. And obviously the question is can we build on ivosidenib? Are there newer drugs that we can think through? And how can we target this very important target? It's 15 to 20%, we think, of cholangiocarcinomas, and so a sizable chunk. So this is the LY compound. It's got a very long number. I call it LY. This is some of the early work that demonstrated potentially, at least in preclinical models, greater potency and more durable efficacy than ivosidenib. And these, again, are all in vivo. And as you can see here, it really seems to be a potent inhibitor of 2-hydroxyglutarate, which is the oncometabolite for this pathway, and seems to be more effective compared to the ivosidenib in vivo models. It also seemed, at least in this preclinical work, to be able to remain active in the setting of resistance mutations that have been identified, that are second-site ivosidenib resistance mutations that have been described. And so that's kind of where the interest with this compound came about. And what we're looking at now is an ongoing study with the LOXO compound in patients with advanced solid tumors and IDH1 or IDH2 mutations. And I think that's an important point here, because Thus far, we do not have something in the clinic available for IDH2 mutations in cholangiocarcinoma patients. Now, this is a smaller percentage of our patients, but still a very relevant population, of course. And so this ongoing phase 1b study involves multiple dose expansion cohorts after the dose escalation. And as you can see, one is a dose expansion specifically for patients with IDH1 or IDH2 mutations with cholangiocarcinoma. There is also a frontline cohort of GemCis plus LY that, of course, is relevant and interesting to us to see what combinatorial effects can happen with cytotoxic backbones and IDH inhibition. So this study is ongoing, and obviously, because this is a phase 1, the main primary outcome was recommended phase 2 dosing, but we're hoping that we'll get some signal in terms of efficacy and what this is really doing in our patients shortly. I'll briefly mention NTRK fusions. As we all know, NTRK fusions are it was called the Lazarus drug when these drugs were first tested in the phase 1 setting. This includes larotrectinib and entrectinib. This is an important thing to identify, but I would call it a needle in a haystack. It's very, very rare in cholangiocarcinoma patients. But this, as you can see, this waterfall plot demonstrates the larotrectinib activity at least, and you can see that there was a cholangiocarcinoma patient that had a very impressive and deep response in the initial data that came out with larotrectinib. And there you can see the breakdown in terms of the incidence of NTRK fusions across a myriad of tumor types, including cholangiocarcinoma. But I think another interesting space is really HER2. So HER2 amplifications, alterations are seen in biliary tract malignancies, little less commonly in intrahepatic cholangio, a little bit more common in extrahepatic cholangiocarcinoma and gallbladder cancers. But a number of studies have looked at different ways of targeting HER2 in our biliary tract cancer patients, and this was the My Pathway study that was published in 2021 that looked at a combination of trastuzumab, a known monoclonal antibody, with pertuzumab that target dual targeting of HER2. And as you can see in the biliary tract cohort, which was 39 patients, patients were enrolled across different biliary malignancies, intrahepatic, extrahepatic, gallbladder, and ampullary cancer were all represented here. And I think it's just important to point out that this was a pretty refractory patient population. And in this refractory patient population, we saw a response rate of 23%. 9 out of 39 patients had a partial response. And the swimmer's plot on the left demonstrates that some of these patients actually stayed on this targeted regimen for some time. So clearly, HER2 is targetable. And what we also noted in this, again, refractory patient population is there was a reasonable sign of efficacy in terms of both progression-free survival and median overall survival as well. So that, of course, sparks interest and makes us think that there are potentially ways to target this important pathway in biliary cancers. And so there are a number of other ongoing studies, with HER2 targeting agents, and one of which is Zanidatamab. So Zanidatamab is a biphenotypic monoclonal antibody that simultaneously binds to 2 different spots on HER2, the extracellular domain 4 and extracellular domain 2. What that does is it has a number of kind of downstream impacts in terms of improved binding, clustering, and receptor internalization, as well as downregulation, and ligand-dependent and independent proliferation that is inhibited. So this drug was of great interest to us in the biliary cancer world, and Dr. Merrick Bernstein presented some of the initial data with this drug in biliary tract cancer patients at GI ASCO in 2021. This was 20 patients, again, refractory patient population with single Zanidatamab in these patients with a 40% response rate. Again, look at that waterfall plot. Most patients seem to derive some benefit from HER2 targeting. And so what that has led to is a great interest in what this drug can do in a larger group of patients. and that is the Horizon BTC-01 study. So this is a multi-center study that is ongoing. It is an open-label, single-arm study that is looking at single-agent Zanidatamab in patients with HER2-amplified biliary tract cancer. So these are patients that are across biliary tract malignancies, but obviously will be probably predominantly extrahepatic cholangios and gallbladder cancers, but any biliary tract cancers are allowed. And they need to have progressed on gemcitabine-based therapy, so at least one prior line of therapy. This is the study design, and as you can see, the planned N is 100 patients, with 75 patients planned to have the standard, as we define it, HER2 amplified definition of HER2 IHC 2+ or 3+. 25 patients will be enrolled with kind of a lower IHC HER2 positivity of 0 or 1+. So hopefully that will also give us some insight into whether or not this drug has any sort of efficacy in HER2 that is lower in terms of amplification. And Zanidatamab, as you can see, is an every 2-week dosing schedule, and the primary endpoint is confirmed overall response rate. So this is your typical, just as we've seen in other targeted therapies, single-arm open label with an overall response rate primary endpoint study. So let's move on to some of the other rarer tumors, rarer alterations that are still very relevant. So let's talk about NRG fusions. NRG fusions, or neuroregulin 1 gene fusions, are very rare. They are early oncogenic drivers, and they are found in a very small percentage of biliary tract cancers. Specifically, both gallbladder and cholangiocarcinoma have been identified. Now, as you can see, NRG1 is the predominant ligand of HER3, and to a little lesser extent, HER4. And so this pathway is still kind of involved with downstream activation of the HER pathways when you think through tumor proliferation and cellular dysregulation. Now, as you can note here, even rarer, possibly, than NTRK could be NRG1 fusions. It's hard to know because there are a number of different reports in terms of the incidence of NRG1 fusions in biliary tract cancers. In the pie chart, you'll see this was a little over 50 some odd samples of different tumor types, and here 6% of cholangiocarcinomas had NRG1 fusions, so very small in numbers. Gallbladder cancer, as you can see on the graph at the top left, 3 out of 580 samples. So rare, but an incredibly important one to find because we have ways of targeting these now. First is seribantumab. Seribantumab is an anti-HER3 monoclonal antibody, and it inhibits HER3 in the downstream pathways, as I already mentioned. It does that through NRG1-dependent inactivation of NRG1 HER3, as well as preventing the HER2 and HER3 dimerization. These two things then downstream impact the PI3K and MAP kinase pathways. So it's a dual activity in terms of this drug. And so far, what we know about seribantumab is in early studies, the safety profile seems to be a very well-tolerated drug. And that's what's led to the phase 2 tumor-agnostic basket trial, which is the Crestone study. As you can see, there's the pivotal cohort 1, which is 55 patients, and then there are 2 exploratory cohorts. In the total 55 patients that is the pivotal cohort, these are patients who have received no prior ERBB, HER2, HER3 targeted therapies. And then the exploratory cohorts include patients who have received prior HER2 targeting or ERBB targeting. And then the cohort 3 are NRG1 fusions with without an EGF-like domain. So it's a slightly different type of cohort, as well as people who don't have enough for central confirmation of the presence of this fusion. In this study is ongoing at multiple sites, and we have not yet seen any early data out of this study. That being said, we have another drug, and that is the zenocutuzumab. This is the NRG1 development program for Zeno, and in this study, this is a phase 1 rolling over into a phase 2 study, and some of the initial data was presented by Dr. Shram at ASCO. And as you can see, this is in all patients with an NRG1 fusion, any tumor type, solid tumor type, and they receive this drug every 2 weeks, and the planned enrollment is 61 patients. So this is the efficacy that was presented at ASCO this year. And as you can see, there's one yellow line there that is the cholangiocarcinoma patient that was presented. This is that patient. This is a 48-year-old gentleman who had 2 prior lines of therapy, gemcitabine, cisplatin, as well as S1, had multiple areas of metastases, liver, lymph nodes, and lungs. And this was their baseline, and then after 4 cycles scans, and you can see the drop in the CA19-9 on the right, as well as the change in the target lesions. So this patient had a 32% reduction in their target lesions and qualified as that one partial response that you saw in that waterfall plot. So N of 1 right now, but it's a rare finding and definitely provocative and intriguing, and we need to continue to follow these 2 drugs that are currently in clinical trials. And then, of course, we have DNA repair. So the DDR pathway we know is incredibly relevant. DDR includes things like microsatellite instability. We know that microsatellite instability high is a rare finding in cholangiocarcinoma, but the percent of patients who have defects somewhere in the DDR pathway is actually much greater and is probably on the order of 20 to 25% of our patients. And I just have this graphic here to just demonstrate the myriad of genes that are involved in the DDR pathway that we think through when we talk about a patient with a potential DDR defect. So in defective DNA damage repair, there's that pathway that there's those genes that I just mentioned in that pathway. We think that's really on the order of 25, 35% of patients could have alterations in any of these different genes. And that, of course, includes the traditional ones we think through, like BRCA1 and BRCA2, but also includes other genes within that homologous recombination pathway. What we also think is that there is at least some preclinical data that suggests this, as well as just scientifically rational thinking that suggests that patients with IDH1 mutations also demonstrate a DDR type of phenotype. And so there's a large component of our patients who may have some sort of potential sensitivity to PARP inhibitors. And PARP inhibitors, as we know, are FDA approved in drugs like in diseases like pancreas cancer and breast cancer and ovarian cancer in patients with BRCA mutations, and are being explored in a number of other tumors, specifically in that DDR phenotype. Some of the initial data that really came out of Dr. Saab and Dr. On's group demonstrated that patients with BRCA1 and BRCA2 mutations in biliary cancer, overall, their median overall survivals seem better, suggesting maybe a prognostic implication to the presence of BRCA mutations. We've seen this similarly in pancreas cancer, and so that's kind of an important thing to keep in mind for us to explore better. And importantly, in this study that Dr. Saab and Dr. On had looked at, there were 4 patients who were actually treated with PARP inhibitors. And as you can see, their progression-free survivals on PARP inhibitors ranged anywhere from 2 months all the way up to 42.6 months. Again, just kind of raising your eyebrows and making you think that perhaps PARP inhibition could be something to consider here. And so that's what's led to the ACCRU 1702 study, which is a phase 2 study of Olaparib, an oral PARP inhibitor, in patients with aberrant DNA repair in biliary cancers. So this is a 2-stage design study. So 18 patients will be enrolled first. If it meets the go, no-go mark, then an additional 14 patients will be enrolled. And the primary endpoint here is overall response rate. So I think this will be an important study for us to really understand PARP inhibition in this patient population. And then lastly, we have MDM2. So this is kind of a new area of great interest and excitement. What we know is that there is an interaction between MDM2 and P53 and this kind of balance that these two provide to each other. And that's why I called it the regulator. So the MDM2 oncoprotein is basically plays a critical role in P53 activation and degradation. And so what we know is that overexpression of MDM2 leads to P53 degradation and aids tumor proliferation, which is where the concept of MDM2 inhibition came about. MDM2 amplifications in cholangiocarcinoma are rare. It's on the order of 3 to 7%, depending on what report you read. But again, rare but important potentially. And so BI 9078828 is a potent MDM2 p53 agonist, and it seems to kind of exert its impact in two different ways, both through direct targeting of the MDM2 p53 balance, as I just explained, as well as through some through some immunomodulation of the tumor microenvironment. Some of the work suggests that there's, with this drug, a decrease in Tregs, an increase in CD8 positive T cells, and kind of a activation of immune memory. And so this is a drug that is of interest and has been being looked at in an early phase 1 study with primarily sarcoma patients, but there is suggestion of activity perhaps in biliary cancer patients as well. This is that phase 1 study, and hopefully we will get some more information with the biliary cancer cohorts soon. So in conclusion, I don't really think there is one GOAT. There is not one greatest of all time. I think we have a really important job to do here. There are many potential targets in biliary tract cancers, and upfront biomarker testing, I'm sure we've heard this 100 times already today, is essential. These rare alterations are crucial to find because we now have trials for these patients, and we may soon have drugs available for these patients. And so comprehensive testing, looking for fusions, looking for alterations, mutations, amplifications is going to be very important here. And then, of course, with targeted therapy, as we have learned, comes resistance. And so understanding resistance and second-generation inhibitors, such as in the FGFR space, which is our model for this, let's learn from that story and figure out how we can think through it and circumvent resistance that will inevitably emerge. And so I think it's going to be a little bit of, we need both Tupac and Biggie here. We need all of these drugs available to our patients. Thank you very much.
Thank you for that excellent talk, Dr. Shroff. That was a tour de force of many exciting targets, and it's great to see that there's several biliary-specific cohorts and biliary-specific trials in some of these less common targets. It's a path to approval, so we're excited about that. It is my distinct honor and pleasure to introduce our next speaker, Francesco Facchinetti. He did his medical oncology training at the University of Parma, and now he's a PhD student in Luc Fibrellay's lab at Gustave Roussy in France, close to Paris. And something that my co-chair Jesper Andersen and I did intentionally for this conference was try to invite young people who are not yet necessarily working so much in cholangiocarcinoma to bring them into this wonderful community that's the cholangiocarcinoma community and have them get this energy from this conference. So people like Greg Poor this morning. And Francesco actually has his expertise in lung cancer. And I've had the distinct pleasure of spending more than 100 hours with him over Zoom in the last 4 months, writing a paper on FGFR resistance. And he's going to be talking about FGFR resistance today. And today's the first time, or this conference is the first time that I'm meeting him. And he's a lot taller in person than I thought he was in Zoom.
Good afternoon, everyone, and thank you very much for the kind invitation and for the very kind introduction. So I will spend the next 15 minutes talking about and sharing some ideas and some data about overcoming resistance in FGFR-driven cholangiocarcinoma. And as said by Dr. Goyal, I will try to bring some experience that I borrow from oncogene-addicted lung cancer, but you will see that it will be a going back from lung cancer to cholangiocarcinoma. This is my conflict of interest disclosure, and this is my outline. So we will talk about novel approaches, but we have to deal with the established approaches as concept in studying resistance to targeted agents. We will approach which are the mechanism of resistance to FGFR inhibitors in cholangiocarcinoma and how we can overcome resistance. So with established or potential approaches, namely next generation inhibitor and combination therapy respectively. And then these two, the second and the third point, will be very, very exchangeable during the presentation. And then we will finish with a global perspective on the role of integration in really understanding resistance. I had the privilege in Paris during my PhD to work in the Marcher program that is an extraordinary source of biologic material from patients before, during, and at progression to any kind of anti-cancer agents, and that brings us to establish patient-derived xenograph and cell lines, and to have a high-throughput sequencing of both tissue biopsy and ctDNA. And just to provide you some numbers, so from Machar that started in 2015 thanks to my PI, Luc Friboulet, and then this data have been collected thanks to Dr. Flores. Almost 900 patients underwent tissue biopsy, almost 300 in the immunotherapy group, that with the targeted group and the hormonal therapy group represents the biggest number. And with regard to the targeted therapy group, we have 41 patients in the FGFR population, and thanks to Dr. Olbeck, we had a total of 23 FGFR2-driven patients, FGFR2-driven patients belonging in the large Mature study, for which tissue biopsy, ctDNA, PDX, and patient-derived cell lines are indeed available. Moving to the real concept about resistance, we know that administering kinase inhibitor, in this case FGFR inhibitors, stop the signaling from the receptor that is aberrantly signaling to the intracellular domain and to the nucleus, stopping proliferation of the cells and leading to clinical response. Nevertheless, resistance appears, turning out in clinical progression, and schematically this can be distinct in three main categories. So we can have mutation in the target that precludes drug binding and make the downstream signaling still active. The drug can still binds to the target, but then bypass tract activation maintains the signaling, and other mechanisms less known and less studied, like epithelial mesenchymal transition, epigenetic regulation, and apoptosis regulation, can be involved. In non-small cell lung cancer, in other solid tumor, the vast majority of evidence is they deal with mutation in the target, so on target mechanism of resistance. And also in this talk, we will deal more about this topic, but also bypass tract activation are completely of interest. So we know by the pivotal work of Dr. Goyal that mutation in the targets are indeed play a major role in cholangiocarcinoma. And what we learn from this first paper is that mutation at progression to first generation FGFR inhibitors are mainly detected in the ctDNA compared to tumor biopsy, and we observe polyclonality of resistance. So in a single patient, we have a multitude of mutations that arise. This was confirmed later on in another relatively small series when, again, ctDNA was able to catch a multitude of resistance in several patients. And so which are some of the important concepts that distinguish FGFR to cholangiocarcinoma from other oncogene-driven disease? That it's from here that I started noticing that ctDNA liquid biopsy is completely irrelevant, and then I realized that polyclonality is something that it's biologically and clinically relevant. We never saw this kind of multitude of mutation after progression to a targeted agents. This is the case right now with KRAS inhibitors in lung cancer. We have some evidence in this sense. We deal with polyclonality, but then all the mutation has the same degree to inhibitors, so have the same clinical meaning, may allele frequency be informative? In this sense, these are kind of open questions. Nevertheless, we know that from first-generation inhibitor, we need to develop new generation inhibitor to overcome on-target resistance. And this is a recapitulative table about the FGFR inhibitor available or in clinical development across solid tumor. Infigratinib, pemigatinib, FDA approved, futibatinib with an accelerated approval, and futibatinib with the molecule from Relay that, to my eyes, but also to the expert in the field, with their capability of targeting FGFR in a very irreversible way, and RLY 4008 with its selective FGFR2 action could be the really next generation inhibitor. To characterize and to say that a molecule is a real next generation inhibitor, we had to take a step back and characterize the mutation. So ask ourselves if the mutation that we see in patients are really causing resistance, and to watch to engender resistance. So what was my job in the lab was to engineer cell lines to switch their dependence from interleukin-3 to an FGFR2 fusion in this case with BIC1, that is the driver, insert single FGFR2 mutation that we saw in patients, and evaluate them in preclinical models, testing the drug sensitivity, and we are very happy when the curve tend to, in this case, to the left, indicating that a low concentration of the drug is necessary for reaching a cell death of 50%. That is our main readout. And all the job of 2 years of, or mainly maybe more of passion and dedication is represented in this table. And beside all the data that is presented here, we could spend hours in discussing that, but the three main elements that I would like to share with you is the action of all the inhibitors that we have against the wild type fusion protein BIC1 or CCRC1. So the lowest the value, the most important is the term that we call potency. Then when I started working with this drug, I realized that the molecule from Lilly was kind of impressively active, but then looking at the action and the IC50 that he had against parental cell line, I realized that maybe it was a toxic drug. So its target was FGFR, but not only. So we kind of discarded, and indeed the molecule is no longer developed. And then looking at some interesting resistance mechanism, we acknowledge that the gatekeeper mutation at that position, in this case Wu564, but that can be coded again Wu565, are the most interesting one and are likely the target of future inhibitors. So from our preclinical work, Dr. Goyal had already stated that we can overcome resistance to first-generation inhibitor, ATP competitive inhibitor, with futibatinib, with clinical and preclinical proof. So recognizing that futibatinib can be active in patients that develop or not FGFR2 mutation after ATP competitive inhibitor, and as I could not work with the molecule from Relay in my experiments, I report here the data that confirm that it could be a very nice drug and active against the most common resistance mutation. And this, again, was translated in a clinical efficacy in terms mainly of tumor shrinkage, in patients progressing to pan-FGFR inhibitors. Sorry. So moving from on-target resistance to bypass tract activation, I will share with you one lesson from another FGFR-driven tumor, and we talk then of cholangiocarcinoma. We established indeed a cell line from an urothelial cancer patient with an FGFR3 mutation that was progressing to erdafitinib, and we realized that the cell lines was not hyper-expressing, but have a hyperphosphorylation in EGFR, meaning that a bypass tract led by EGFR was likely in place, and we reverted the resistance to erdafitinib thanks to the combination of erdafitinib with the EGFR inhibitor gefitinib, with a nice readout both in IC50, both in Western blot, and going to the in vivo part to the mouse, we had a nice, again, synergistic effect of the combination without relevant toxicity. And I think that tomorrow we will hear more about this kind of potential combination in cholangiocarcinoma by Dr. Wu. And it was quite astonishing to see this story provided by Dr. Olbeck about a patient that responded to pemigatinib, but then progressed again with a multitude of mutation in FGFR2, but also with a mutation of TSC1 detected in this case in tumor tissue, and as the possibility of targeted therapy with FGFR inhibitors was finished, Dr. Olbeck switched the patient, trying to maintain in a molecular targeted therapy, to an mTOR inhibitor like everolimus, obtaining a very nice, let's say, biochemical or biological response in the allele frequencies of mutations and also of the fusion FGFR2-BIC1, and obtaining a clinical significant disease stabilization of the disease. So try to recapitulate what we have seen and trying to moving ahead. Thus far, we have dealt with ctDNA, with biopsy, with engineered cell models, and with patient-derived models. Nevertheless, in papers and in studies that are already available, we know that rapid autopsy can help us to really understand the evolution of resistance and the heterogeneity, both in terms of space and time, and we know that structural modeling of mutation can help us to predict how a mutation can cause resistance to specific inhibitor. And so we think, and we, in terms of, I speak for Dr. Goyal and for myself, that the integration of these approaches that encompass the approaches that I share with you, but also the PK, the concentration of the inhibitors, and also a very intense study of the published data on mutation, on other kind of mutation, is the key to understand resistance. And this kind of integration really requires a lot of mental energy, but it's really something that also brings pleasure, let's say. And indeed, we have this transoceanic collaboration led with Lipika, and our aim is really understand the biology of resistance through a landscape approach, through the really scratching our head, get all the elements that we can in understanding which is the biology of resistance, and to involve a lot of people with different specialty backgrounds, acknowledging that everyone can bring his contribution, always trying to understand a piece of this big puzzle, and acknowledging that every pillar, as we call them, can contribute, that really the the vision of all these elements can bring clarity to the resistance spectrum. So these are my take-home messages. And for us, what happens in the clinic, so the patient is really our trigger, both for giving us the motivation, but also because what is the clinical reality of resistance that bring us moving ahead. The integration of several evidence is crucial for understanding the biology. And as a lung cancer guy, let's say, I can acknowledge that the resistance in this kind of cancer, in FGFR-altered cholangiocarcinoma, is extremely complex and unique. And we need to integrate the elements that we saw, but we have to take care, and I talk to myself, that integrating information from other oncogene-driven disease can be misleading. And finally, I started my presentation saying that I like to bridge concept from lung cancer to cholangiocarcinoma, but what I'm doing here and doing now, and I will do in the future, is trying to bridge elements from from cholangiocarcinoma to other tumor types. And sorry, I have another. So it's a pleasure to me to really thank you for the attention and to thank all the people that work with me in the lab. I thank Dr. Olbeck, and I'm really thankful, and I'm really lucky to work with Dr. Goyal and Dr. Di Toro in this kind of work of passion about our landscape resistant project. Thank you very much.
That was great. And we're a little bit behind, but we're going to carry on. And it's my great pleasure to introduce our dear colleague, Dr. Shahid Khan from the Imperial College in London. Dr. Khan is on the Faculty of Medicine, but also he's a liver cancer specialist, great colleague we work quite a bit with and the team. And he's actually coming to talk to us about a very important subject. Please, this is really a critical item that we all need to really understand better and understand what's behind it from and beforehand. And now with the advent of all the nice therapies that we heard Dr. Shroff and Dr. Facchinetti talk to us about. And the subject is why we need correct ICD coding for cholangiocarcinoma. Shahid is going to be by recording. The floor is yours.
Hello, everyone. My name is Shahid Khan. I'm a consultant specialist professor in liver disease at Imperial College London. It's a real pleasure to be giving this talk. I'm very grateful to the organizers at this great conference. I'm so sorry I couldn't be there in person. Hopefully next year I will be able to. But it's a real pleasure to be part of this, even though it's remote. I've been asked to talk about why we need correct ICD or international classification of disease coding for cholangiocarcinoma. Here are my disclosures. So cholangiocarcinoma, as I'm sure everyone listening is aware, is an aggressive cancer malignancy arising from the biliary tract epithelia, so the lining of the bile ducts wherever they are in or out of the liver. It is most common around the 7th decade and above in age, so it's a disease of sort of middle-aged and older people predominantly. It affects both men and women with a slight preponderance towards men, but only slightly so. And the intrahepatic, so the version, so the cholangiocarcinomas that arise within the liver parenchyma itself are the second commonest cause of primary liver cancer globally after HCC, hepatocellular cancer. And it is an aggressive cancer. The overall 5-year survival is quite dismal at less than 5 to 10%. Now, there are subtypes of cholangiocarcinoma: intrahepatic, perihilar, and distal, depending on where in the biliary tree they arise. An example of intrahepatic, which arise in the liver parenchyma above the second order bile ducts. The distal or extrahepatic cholangiocarcinoma arise below the cystic duct, and the perihilar cholangiocarcinoma arise in between, in the sort of hilar area. And according to case series and clinical experience, around 50 to 60% of cholangiocarcinomas are perihilar. This is the majority of the cancers. And around 20% are distal, and about 10 to 20% arise in the intrahepatic bile ducts within the liver parenchyma. Now, what's interesting about these three subtypes is not just that they are anatomically different where they arise, but they also have distinct epidemiological trends. They have distinct pathobiology, risk factors seem to affect these three different types in different ways. And the way they present clinically differs, and the way they are managed can have differences as well. So they are distinct. Now, when I was a very young medic doing my PhD, I did it on cholangiocarcinoma. And one of the things that we found in our group was that the age-standardized mortality rates, or ASMR, seemed to be rising in many countries around the world. And this was the first publication on this. And it was the intrahepatic cholangiocarcinomas that seemed to be rising when one looked at the worldwide rates. And then there was a paper from my friend and colleague, Tushar Patel, who looked at more countries and found that the intrahepatic cholangiocarcinomas, looking at the EAPC, the estimated annual percentage change in men and women. Men are in the white bars, women in the black bars, across all continents. And again, he found the same thing, that the intrahepatic cholangiocarcinoma genes were increasing in both genders pretty much globally, and extrahepatic seemed to be going down. And since those studies 20 years ago, there have been a range of multiple studies from multiple groups around the world finding essentially the same thing. And one of the most recent papers was this from Bertuccia et al., published in 2019. And what they found was that the highest rates, so the cholangiocarcinoma rates here, men and women, men are in the top lines, women in the bottom lines from all these countries. So Austria, Germany, Hungary, across the European Union. At the bottom here, we've got Venezuela, Hong Kong, Japan, Australia. This continued rise that we reported that had been going on from the 1970s and 80s had been continuing. Particularly highest rates in France, Spain, UK, and Australia. And the extrahepatic rates seem to be going down, although that's not shown in this graph, they seem to be stable or going down. And this shows the, from Bertuccio's paper, again, the intrahepatic cholangiocarcinoma and differences in men and women in selected countries and extrahepatic cholangiocarcinoma. This was a study done by HCC UK, which looked at deaths from liver cancer over a recent 20-year period in England. And they found that deaths from liver cancer tripled. And although traditionally we're taught that HCC is the commonest liver cancer, what they found was that of the over 62,000 cases of primary liver cancer in this 20-year period from the late 1990s in England, almost 40% were actually intrahepatic cholangiocarcinoma, which was quite a surprising finding, showing that cholangiocarcinoma is increasingly important in terms of its clinical impact in relation to liver cancer. So multiple studies have consistently shown that when one looks at incidence and mortality rates, which are very similar because there is such a high mortality rate from cholangiocarcinoma, that when these rates are increasing for the intrahepatic variant, but decreasing for the extrahepatic variant, and it's not a simple seesaw effect. Overall, if you add the two of them together, cholangiocarcinoma is increasing. So it's not that extrahepatic is going up at the same level as intrahepatic is going down. Overall, it is increasing. So the question is why? Why is intrahepatic cholangiocarcinoma going up? Is it really intrahepatic cholangiocarcinoma going up? In clinical practice, it's the perihilar variant we see more and more of. And is it because of better diagnosis? That may partly explain some of it, but this consistent rise appears very biological. Is it better awareness? And what is the role of coding? And this is what I'm going to focus on, the impact of coding. And this is what I'm going to be talking about for the rest of the talk. So I need to talk about the coding systems. So every disease is given a code. These codes are registered on databases nationally and then uploaded on international websites. And that's how scientists and clinicians monitor rates of diseases around the world. Now, the main coding system that is used is the ICD, that's the International Classification of Diseases, which is overseen by the WHO, the World Health Organization, which lists all known medical diagnoses, whether it's cancerous or non-cancerous. And the ICD is currently in its 10th version, and it changes every few years to keep up to date with new diagnoses, advances in diagnoses, knowledge, etc. The newest version is going to be ICD-11, which is just coming out. Now, ICD-10, all the ICDs list topography codes, which describe the anatomical site of the organ, of the origin or of a tumor. Now, it gets a little bit complicated here, so I'm going to try and take you through this slowly. And it took me a while to get my head around it. Now, the WHO has this specialized cancer agency is IARC, which is based in Lyon, in France. And IARC produce a separate ICD code called ICD Oncology, ICD-0, just for cancers. So cancers will have their own main ICD-10 code, but they will also have an ICD-0 code. And the ICD-0 code consists of two separate codes. The topographical code, which describes the anatomical site of the origin of the tumor, where the tumor came from, and the morphological code, which describes its cell type or histology. So you have these two ICD coding systems in parallel. Now, what appears to be the case is that these ICD coding systems may be leading to inaccurate recording of the cholangiocarcinoma data. Not saying that cholangiocarcinoma isn't increasing, but in terms of which type is increasing. So ICD-10 and all the preceding ICD versions, the main ICD coding system, has a code for intrahepatic cholangiocarcinoma and for distal extrahepatic cholangiocarcinoma, but does not have a separate code for perihilar cholangiocarcinoma, the main type of cholangiocarcinoma C. That does not have its own code. It's missed right at the beginning. ICD-0 has a morphology code for perihilar cholangiocarcinoma, but in terms of its main coding, it's sometimes cross-referenced to intrahepatic and sometimes to extrahepatic, depending on the version of ICD-0, which also changes every few years. So when people look at the data, they tend to look at the ICD-10 coding, which doesn't have a code for perihilar. ICD Oncology has a code for perihilar, and remember, perihilar is a common type of cholangio, but sometimes this is cross-referenced to intra and sometimes extrahepatic in the main ICD code. And what complicates things further is that the main ICD system and the ICD-0 change every few years. And further complicating it, different countries adopt the new versions at different times. So when a new ICD or ICD Oncology comes out, it's not like internationally every country starts using it on the same day. They gently merge into it over time, and it varies from country to country. So the coding of perihilar cholangiocarcinoma. So these perihilar, or sometimes called Klatskin cholangiocarcinoma, are technically they're extrahepatic, but they're not specifically differentiated in routine data. In the first version of ICD oncology, they weren't called perihilar, they were called Klatskin, and named after a US pathologist and hepatologist who first described them about 70 years ago. Klatskin cholangiocarcinoma, or perihilar as they really are, were not assigned a specific code and could have been classed as intra or extrahepatic. It was pretty random. When ICD-02 came in, someone thought, this isn't good. We need to specify this to one or the other, but incorrectly cross-referenced it to intrahepatic rather than extrahepatic. And ICD-02 was adopted in the USA in 1991 and in England and Wales in 1995, 4 years later. And then when ICD-03 came in, it went back to ICD-01. It was these perihilar or Klatskin cholangiocarcinomas were cross-referenced, and it could be again back to either intra or extrahepatic. And ICD-03 was adopted in the US in 2001 and the UK in 2008. So basically, under all versions of ICD oncology, this, especially the second version, perihilar cholangiocarcinoma, were likely misclassified, probably to intrahepatic. So let me show this, what this does on the graph. So, so basically, if we look here, the trends in age standardized incidence ratios for tumors coded as C22-1, which is intrahepatic, C24 extrahepatic, between 1990 and 2007. The blue line represents intrahepatic, the red line represents extrahepatic. And then during the time of ICD-02, and then ICD-03 comes in around 2001. And then look what happens to the graphs after that. They basically flip, and I see an intrahepatic goes down, extrahepatic goes up, and that cannot be biological. That is a sign of artifact from coding, graphically represented. More recently, myself and colleagues did a study in England to look at the real world data rather than looking at data sets. So at 3 independent regional hepatopancreaticobiliary centres around the country, 2 in London and 1 in Northern England, we dug out the case notes of all cholangiocarcinomas over a 2-year period to see what the diagnosis really was and what code they were allocated. So it's a retrospective study. We looked at the MDT, or tumor board notes, the imaging, the reports, and the clinical notes. And what we found was that the patients that were assigned a code for C22-1, which is intrahepatic, the actual diagnosis in 33% of them was perihilar cholangiocarcinoma, not intrahepatic. 43% of them really were intrahepatic. And if we look at the 625 cholangiocarcinomas, 226 in total, 226 were coded as intrahepatic. 43% of them were true intrahepatic, but 34% were actually perihilar. And when we looked at all the cases, we thought, okay, these are the perihilar cholangiomas. What were they classified as? What were they classified as? Having reviewed the real world notes, the real imaging, we found that 92% of perihilar cholangiocarcinomas were incorrectly coded as intrahepatic. So they were perihilar and they were coded as intrahepatic, not extrahepatic, not perihilar, because there is no perihilar code. And if we looked at this data set, distribution of cholangiocarcinoma patients by subtype, according to the official data, only 1% of cholangiocarcinomas were perihilar, which is ridiculous. We know as practicing clinicians that it's nearer 50%. So basically, we need international consistency and accuracy in how we classify cholangiocarcinoma. Otherwise, we're not going to be able to accurately monitor disease rates. Bile duct cancers should be clearly subclassified as intrahepatic, perihilar, or distal. We should probably abandon the term Klatskin. They have different epidemiology, pathobiology, presentations, and management. We need to interpret the trends with caution. Cholangiocarcinoma rates probably are going up, but we need to be clear which types are going up. And we need to record the data uniformly and accurately. So the data that we record in hospitals that goes to the cancer registries, we've got to be really careful how we record that. And the responsibility to do so isn't just with the cancer registries, but also with the clinicians. We need to be very careful about that. And myself and colleagues have, for a long time now, made the case that next version of ICD-11 and subsequent versions of ICD oncology should have separate topography and morphology codes, not just for intra and extra hepatic, but for perihilar cholangiocarcinoma as well. And here at home, at my home in England, on behalf of Cholangiocarcinoma UK, we've had discussions with the head of cancer data sets at the English National Cancer Registration Analysis Service. And from last year, their new data set will have 3 separate codes for intra, extra, and perihilar cholangiocarcinoma. And I'm pleased to say that the next version of the ICD oncology, the main ICD system, will have 3 separate codes: hilar, intrahepatic, and the extrahepatic or distal bile duct. So these are the codes that will come in. It's important now. So now that we really going ahead to have different codes for these 3 cholangiocarcinoma, it's important that we use them. This will not correct the inconsistencies and inaccuracies of past data, but at least going ahead, we will have more accurate data. I think it's important to note that my take on it is that however we are classifying cholangiocarcinoma, its overall incidence and therefore mortality seems to be rising. We need urgent studies into its causes, and we need better and more effective therapies and better ways to diagnose it early. I'd like to thank many sponsors and support and grant givers and colleagues who've helped me in this work. Thank you very much.
We are going to move on to Dr. Ryan Fields' talk right now, and then after that we'll take questions for all 4 speakers. So Dr. Ryan Fields from Washington University at St. Louis is going to talk to us about a very exciting project that he's working on, the Cancer Genome Sequencing U2C Cancer Moonshot Program. It's really an honor to have you, Dr. Fields. Thank you.
Thank you very much. It's been a great session, and I really hope some of what I'm going to talk about will synergize with some of the previous talks. I'm going to talk about a newly funded program that we have up and running at Washington University in St. Louis. And I really want to present this to really everyone in the room. So this is for patients, this is for caregivers and providers, this is for physicians and researchers, because there's a huge opportunity for partnership here, both with the data that we'll generate, both with ideas for new projects that can synergize on top of this, and of course for patients to be engaged and participate both in the research itself and in the process of improving what we see as a real bottleneck. So no disclosures for this talk. I want to go back to 2015 when the Cancer Moonshot started. A lot of people are familiar with that, but long story short, it was an initiative that infused a huge amount of money into cancer research, and it was sort of a came up with the idea of doing it before they really knew what to do with it. And what I mean by that is they said, okay, we're going to put a lot of money into cancer research. You guys, meaning cancer researchers, figure out how to spend it. So they did. There was a blue ribbon panel that was convened. They came up with a lot of different areas that were important to cancer research. This is, you can see the link at the bottom for the Moonshot Initiative, where you can really see all the different initiatives. And importantly, there were things related to immune therapy. There were things related to pediatric cancers, all the real significant knowledge gap areas. But one of the most important ones was the idea of establishing a network for direct patient engagement. And the goal of this was to, as you can see, engage patients to contribute their comprehensive tumor profiles, to expand knowledge in various cancer types, to really understand everything that would be important there, mechanisms of treatment response and resistance. And one of the overarching reasons for this, establishing really a network for patient engagement, was in a lot of tumors, especially a lot of solid tumors, there was a big disproportionate number of people who participated in trials like this that did not necessarily represent the disease. So very overrepresented by upper middle class white patients, in particular white male patients. So in diseases, whether it was colorectal cancer, cholangiocarcinoma, where that wasn't necessarily the demographic, there were a lot of knowledge gaps. So this is, again, a link on the NCI page that goes into a little bit more nuts and bolts of the direct patient engagement. But when we saw this RFA, this opportunity to work on cancer types, they really wanted to look at understudied cancers, more rare cancers. With our experience in our center and interest in cholangiocarcinoma, we saw that as a natural fit. And one of the things that we thought would be most powerful for our program would be to partner with a group like the Cholangiocarcinoma Foundation to really launch this program and expand its reach beyond just our center. I'm going to skip through some of these to try to kind of have us back on time. But this kind of goes through, again, some of the main bullet points and goals of this whole network. One of the things that I'll just sort of highlight is you could pick any cancer type you wanted when you apply for this grant, and again, the goal is to improve knowledge of rare or underrepresented cancers. This is a snapshot of our program. You can see in the upper left the cancer types we're focusing on include multiple myeloma in Black patients, cholangiocarcinoma, and colorectal cancer in Black patients under the age of 50. So all kind of fitting that bill, and cholangiocarcinoma will be what I'll focus on today. In the lower left, you can see the program's made up of 3 units. The middle unit in red there is the participant engagement unit, which is the group that I lead and where we really need help and partnership, and that's the group that's going to identify patients with cholangiocarcinoma that would participate in this study. As you'll see then, we take existing samples and patient data and integrate them into our unit. We do a lot of comprehensive omics and molecular studies to characterize these tumors. And then part of the overarching theme of this program is to really inform best practices for clinical trial participation, to understand what are the barriers to participating in studies that have a focus of genomic research, how to improve that, how to broaden the reach. So there's a lot of social science and public health science in this third unit, in green, the engagement optimization unit, that really studies this process to try to inform best practices. Again, I'm going to skip through a couple of these. This is the makeup of our unit. The 4 principal investigators are at the bottom, myself in surgical oncology and oncology side. Next to me is Graham Kolditz. He's the head of our Division of Public Health Sciences, a real expert in implementation science and research. Bettina Drake, next to Dr. Kolditz there, is the head of this engagement optimization unit. She's an expert in healthcare disparities in qualitative research related to healthcare outcomes with a focus on cancer. And then Li Ding on the far right, a close friend and collaborator who's the head of our Genome Institute and a world leader in cancer genomics. She's led a number of the TCGA studies in various solid tumors. The project is a 5-year project. It's about $20 million or so, so a very large project that, again, integrates with many of the other sites that are funded by this Cancer Moonshot Initiative. And really importantly, is part of this program involves us taking some of the money and setting it aside for pilot studies, additional work, with the goal of anybody in this room, anybody who's interested in cholangiocarcinoma who has an idea that would like to synergize with us, piggyback something on top of that, it's sort of a bit of an open door in what we can do. We're partnering, as I mentioned, with the Cholangiocarcinoma Foundation, also with 2 other patient advocacy groups, Fight Colorectal Cancer and the Myeloma Research Foundation for these other 2 cancer types. And the reason for that is we don't just want patients in our center, we want patients from around the country. We want to really cast a broad reach. There's really not a limit in a lot of ways to the number of patients we can enroll into this study. Again, I'm going to skip through some of these. So what exactly are we going to do? Well, 2 things I would point out. Patients do not need to come to St. Louis at our center. This is going to work off of all previous biopsies that have been done, archival tissue, tissue that could then be sent to us. And we will work with our research team to then incorporate all of the clinical data and metadata for patients as they're enrolled. And then when we do the science, the sequencing, the omics, and I'll talk about that in a moment, then the idea is we will then return those results to patients and to their providers and really study that process. What did patients perceive from the results of their genomic studies? What did they get out of participating in a research study? What were some barriers to potentially participating that are hard to appreciate from the caregiver side, but that are important to accruing patients to future studies? So a lot of that will be survey-based research. We hope in coming years that we'll be able to come to this meeting and do some qualitative research in focus groups as we have results. We're constructing a patient portal that's part of the larger network for patients or participants to log in and gain access to their results, to the results of the research in general. In terms of at a little bit of a deeper level, what are we going to be doing? We'll be doing standard sequencing that will be in a CLIA-certified setting. That'll be deep whole exome and whole genome sequencing, some targeted amplicon sequencing, work with cell-free DNA for patients where that's available, meaning where there's some blood already available, or we can piggyback on a standard blood draw to have blood come to us, and RNA-seq. And then a whole lot of what we call Tier 3 research sequencing outside of a CLIA setting, where we really hope to shed some light on things related to phenomenon like the tumor microenvironment, where we'll be doing a lot of single-cell omics, both RNA sequencing, as well as some epigenomic studies at the single-cell level. Phospho and global proteomics through our proteomics network and efforts at WashU, and cellular imaging, which will really involve things like Hyperion, CyTOF, as well as a Codex platform that will be really trying to probe the tumor microenvironment. Again, I'm going to skip through some of this. This again shows the pipeline. I'm going to go to one of my last slides really so you can kind of see the flow of the patients through this. So if we start in the upper left, once we identify patients, they'd be enrolled into this study with some early survey work before anything is really done. Then as we review samples and bring samples into WashU for sequencing, choose which samples to sequence, which hopefully there may be some patients that have surgically resected specimens that we can compare to biopsy specimens for some comparative sequencing work. Then we will actually return these results to patients. We have a randomized trial of using a particular tool that we will use, a genomics advisor tool versus kind of standard how we return results to patients with print and medical record, MyChart, those types of things. Once the results are returned, we'll then study that process with the research. We have a participant and a caregiver advisory board that's made up of not only researchers and clinicians, but also patients and caregivers, folks in the community that'll then help us review and ingest that data and then iteratively reinform the process, so we may tweak something in the consent process. We also have a unique process whereby patients that we approach for this study that decline, we kind of have a secondary study that our IRBs approved to then try to understand why someone would have declined and see, are there some misconceptions, are there some barriers to participating that we could then overcome, again with the idea of broadening our ability to study a rare cancer like this. This is a flyer that you may have kind of seen out at some of the tables. We have a number of our research team members that are here today. That the foundation has been nice enough to not only give us a focus group platform yesterday that some in the room may have participated in, but also a table out front where we have a poster and some of this information. There's a phone number, our website, and an email address where really anyone can get some more information, whether that's a patient who may want to participate, whether that's a researcher or a caregiver who has some information, would like to share with us, would like to partner with us. This is a true partnership, and we kind of look at it as a new opportunity for us to really make a dent in some of these important questions in cholangiocarcinoma. I'm going to stop there and then look forward to chatting with anyone throughout the rest of the meeting about this, to contacting us anyway, and of course we'll be here for the panel discussion right now. Really like to thank the foundation for their partnership in this and giving us a platform. Thank you.
Conferences, thinking about how we can collaborate, and you are really bringing together patients and centers and bring it all together. So thank you for your leadership on that. So if everyone's okay with it, we'll take an extra 15 minutes for questions right now and cut into our break a little bit because there were so many exciting presentations. I wanted to give people a chance to ask questions. So if you have questions, feel free to go to the microphone and go ahead.
I have a couple virtual questions, if that's okay.
Yes, I'll grab my phone.
So this is from Bruce Lynn. Rachna, how many people with BAP1 are actually getting PARP inhibitors?
That's a great question. So BAP1 mutations are a frequently found alteration that is thought to be part of the HRD pathway or the DDR pathway. And there are 2 or 3 studies that I know about that are looking at HRD, a definition that includes BAP1. And those studies include have PARP inhibitors as options for these patients. There are not cholangiocarcinoma specific ones looking at BAP1 only, but they are kind of clustering BAP1 in with some of the other HRD alterations and have studies ongoing in PARP inhibitors. What number, I don't know offhand, but there are a number of different trials looking at BAP1 as part of that.
And then a related question from Chandar Kumar Sinha. Are there cases of cholangiocarcinoma in your knowledge with ATM BAP1 mutations who showed clinical response to PARP inhibitors?
So there are, if you actually PubMed this, I did this just for fun yesterday, just to see, and there are a number of case reports that have been, published, these ends of 1s, ends of 3s, with ATM alterations, for instance, with PARP inhibitors. ATM is included in the ACCRU trial as one of the alterations, and so, I would highly encourage looking for that trial if it's near you to enroll in that study. And there are larger basket trials that are looking at HRD that include ATM, of course, that biliary cancer patients would be eligible for, and all of those involve PARP inhibitors.
One more. Your observations on responsiveness to PARP inhibitors in cases with DNA damage, signatures scored by Foundation or Tempus, et cetera, in the absence of DDR mutations.
Yeah, so that's a really hot topic. So there's these ideas of these DDR signatures, and there's a lot of different platforms that are investigating this, and there are companies, for instance, that have PARP inhibitors that have their own in-house HRD signatures that they have validated. I mean, the honest truth is that there has not been prospective validation of these, and the definition and what they're using to define as a positive HRD signature, as you want to call it, are different on different platforms. And so right now, I think we have a lot of intriguing data, but I don't know that we have clarity on what the definition is of a positive HRD signature that correlates with PARP responsiveness.
Yeah, and I would add the importance of working with molecular tumor boards because there's so many ATM mutations and BRCA mutations and BAP1 mutations that may not predict sensitivity to PARP inhibitors or other drugs. And so a lot of the trials actually have a way where your oncologist can send the mutation over to the company, and the company will help decide if that ATM mutation, for example, is one that would potentially respond to an ATR inhibitor or PARP inhibitor, et cetera. So really important to work with our molecular pathologists who know a lot about this. Mr. Riddle.
About the FGFR fusions, I think it's pretty well established that the expected course of events is when somebody with a fusion is treated with one of the inhibitors, that there is a fairly healthy chance that he's going to show a response. And this response will last until some point mutation comes along and instills resistance. What about those who do not respond initially, the ones who progress from the get-go? Are these people who have already, for whatever reason, gotten a point mutation that instills resistance, or is there something else going on?
Very, very nice question, very appropriate question. So actually, in our court, and what we see that it's very rare to have a baseline tyrosine kinase mutation together with a fusion. So there is the activating driver that is a fusion, but the rarity of having a baseline FGFR2 kinase domain mutation also explains that the case that we see in clinical practice that have, let's say, primary resistance are not enriched in kinase domain mutations. We had, for example, in our cases in Gustave Roussy, some examples of P10 loss at baseline that led to irresponsiveness to FGFR inhibitors. So more than something that happens on target, I would look for some other genomic events at baseline in other genes to explain upfront resistance.
Thank you. Dr. Poor.
This is a question for Ryan. So our group has really benefited from large-scale multi-omic sequencing efforts to look for microbial DNA and RNA, as I presented earlier today. But one of the greatest challenges in working with these data sets is that they usually lack the gold standard contamination controls that are used in virtually every microbiome study currently implemented. And in a number of conversations I've had with other people pursuing cancer genomics, especially large-scale sequencing and those from the Sanger Institute, whenever I mention the idea of contamination controls, which comes down to sequencing reagents processed simultaneously alongside samples, a lot of people complain, why would I want to spend money sequencing reagents, right? I'm curious from your perspective, especially given the focus on colorectal cancer, which has a large body of literature now on microbial interactions. Melanoma is also having quite a large body of literature of intratumoral microbiome interactions. I think cholangiocarcinoma has a burgeoning amount of literature. What is your perspective on either your effort or future efforts actually including these contamination controls?
Yeah, so it's, I didn't go into it, of course, because it's getting into the details, but we actually had a meeting with the GCU group, which is led by, as I mentioned, Li Ding and her team, and we were talking about this exact topic because fortunately, we do have the money to do it, and across the network, when we met, all the other teams sort of felt it was a strong emphasis. I didn't mention some of the other groups, but for example, USC is part of this consortium. They're also studying colorectal cancer predominantly in a Hispanic population. But same sort of thing, we all talked about we really need to be able to sort of look across centers, but also look within our own centers and have really good quality control. And we have the ability because of the amount of money to do exactly that. So we're really hoping to be able to do that and protocolize it across the centers.
That's phenomenal, thanks.
I had two questions for you, Ryan, actually. So first, thank you very much for doing a little bit of a shorter presentation to catch us up. That was really kind. So my two questions are, it sounds like something that's very unique about the project that you're doing is that patients will have access to their results. Yep. And I presume that also means oncologists will have access to the results to help patients. And that's the turnaround time on that people can use them as opposed to like 3 or 4 years down the road is an incredible part of the program. And I was wondering what the plans are for helping patients and oncologists interpret whole exome sequencing and how to make that information utilizable for their care. What is the sort of turnaround time you would expect when people send you tissue? And then do you have like a remote consenting process where it's sort of like direct to patient type of marketing is the wrong word, but I don't know what the other word is, but like direct to patient connection where people can connect directly with you, or is it all through oncologists with consent?
So last question will be the easiest one. We can consent remotely, and we have a good process through our IRB of approving that. And our hope is we really interact with patients quite a bit on this, not as their treating physician, of course, but as being able to provide the CLIA-certified results back to them, and then in an aggregate sense, really provide the research results back to them. Not so much because it may affect their care directly, but so they feel like engaged in understanding, well, what did you learn from me participating in this? In terms of the actual return of results, we're not trying to, say, substitute for a standard genomic testing that their oncologist may order and really need back in a rapid way to inform clinical treatments. A lot of patients will obviously probably come in with whatever platform they've used, Foundation One or Caris or Tempus, whatever it is. One of the things we've observed in the focus groups with patients and providers is that some of these results are really hard for people to interpret at all, whether you've got an MD or PhD behind your name or you're a layperson or a patient. It's hard to get a lot out of some of these reports. So our hope is to use this process to better inform how these reports should be presented back to patients and oncologists so that they can be utilized well. And then going forward, what we're really trying to develop within the context of this patient portal in informatics is to track, say, all the results from a patient's tumor profiling, so that if something is not really relevant or actionable today, but we figure out that it's prognostic or predictive or a therapeutic target down the road, that there'll be a trigger so that that gets back to the patient, it gets back to the provider, and really develop a platform that then could potentially be rolled out in a bigger sense that comes out of this network.
I can imagine that would be really helpful for pharmaceutical companies and biotech companies down the road who develop drugs for rare targets to be able to have a sense of, one, who are patients that they can offer that option to, and thinking about patient protection, but really connecting people to those opportunities.
Yeah, I mean, one of the things that's been noted is, places like pathology has these standardized reports that come from their professional organization. You have a report on this tumor type, it's got to read like this, so that there's a standardization. That really doesn't exist in the world of genomic testing and return of results. And one of the larger missions of this is to try to develop something like that across tumor types so that things are a little bit more standardized and understandable and presented.
Thank you.
Could I ask one more question? I've got a virtual question for Dr. Fields. We have patients asking if if their samples can be included posthumously through this program.
They can be, and one of the reasons we've used the word participant and not just patient is if someone has had a loved one that's gone through this journey that's either not really able to participate on their own because of what they're going through now, or if they've passed, we still really value the partnership of anyone who's been a partner, a caregiver, a provider of someone with cholangiocarcinoma, and we have a way through our IRB that our IRB has approved it in order to enroll patients' samples that way as well.
Thank you. Please go ahead.
Hi, my name is Ray Baha, and I'm a caregiver for my nephew. My question is regarding TIPSOVO or IDH1 mutations. If the cancer is spread through the bloodstream, metastasized, and what constitutes a success as far as the TIPSOVO? Besides the affecting the tumor, would that TIPSOVO affect to reduce the density of the cancer on the bloodstream to the point that the patient would be qualified for surgery to remove the tumor? Thank you.
So that's a great question and something that we face in clinic, I would say, quite routinely. In the setting of metastatic disease and IDH1 positive cholangiocarcinoma, which is the setting in which ivosidenib was studied, the success, and again, there's, in my opinion, multiple definitions of success. There's the success that is delineated by a primary endpoint in a clinical trial, and then there's the success that you see in clinic in a patient. And so, I didn't go into the CLARITY study, but the study was designed to show a statistically significant improvement in progression-free survival. So there was a 63% reduction in the risk of progression. So success by the definition of the trial was that ivosidenib delayed progression. So patients either had stable disease or response to therapy did not demonstrate progressive disease, so growth of the tumor in any site that was being followed. Again, I think in clinic, our definitions are different. I mean, to me, any sort of change radiographically, of course, is success. So shrinking of tumor, stability of tumor with improvement in symptoms, clinical, the sense of a clinical burden of disease being decreased. If there's a tumor marker that's being followed, like a CA19-9, some people follow the IDH mutation on ctDNA, and there's some suggestion that clearance of ctDNA correlates with kind of outcomes and things like that. So I think it's a composite picture in clinic in terms of what we define as success for ivosidenib. In terms of it changing the picture and potentials for surgery, typically when something has metastasized, it's not always thought of as a surgical as a possibility for surgery. But I will tell you that there are all kinds of different definitions of metastases and all kinds of different definitions of response to therapy. And a lot of those conversations, that's why it's so important to have a multidisciplinary tumor board conversation when patients are perhaps on a cusp, if you will, and have response to any sort of targeted therapy. And if there is a question, to have that case revisited at the tumor board and have the surgeons either discuss the patient at tumor board or see the patient and get that surgical opinion.
Thank you very much. Thank you to all of our esteemed speakers and Dr. Khan for joining us virtually. Thank you so much. It was an excellent panel. And to my co-moderator, Dr. Abou Alfa, thank you to all of you. We'll come back at 4 o'clock and reconvene. Thank you.